Welcome back to the deep dive. Today, I want to start by putting you in a very specific and I think a very familiar situation.
Okay, I'm ready.
You're sitting at your desk, it's late. You can feel the quiet of the house around you. The glow of the monitor is probably the only light in the room.
I know this scene. This is my Tuesday night.
It's everyone's Tuesday night, and you've got this brilliant idea. Maybe it's a new trading algorithm you're working on, something proprietary.
Or maybe a draft of a novel, right? That one chapter you've been struggling with.
Exactly, the next bestseller. Or, maybe it's a confidential legal strategy for a really high-profile client, the kind of stuff that absolutely cannot leave the room.
The kind of work where every single detail matters, where the nuance is everything, and a leak would be catastrophic.
Catastrophic, but you're stuck. You're staring at a paragraph that just isn't working, or a block of code that keeps throwing an error you just can't wrap your head around.
We've all been there. The wall.
Yeah, the wall. So you do what everyone does in 2026. You open a new tab, you copy that sensitive, proprietary, potentially million-dollar text. You paste it into a chatbot, and your finger just hovers over the enter key.
It's pure muscle memory at this point, isn't it?
Yeah.
It's the modern equivalent of Googling it.
Mm-hmm.
But there is that split second, that little pause.
That's the moment. That is the moment we are living in today. That split second of doubt. Because today, we are pushing the big red button on that muscle memory. We are initiating the nuclear option.
It sounds incredibly dramatic, doesn't it? Like we're about to discuss, I don't know, Cold War geopolitics.
Right. Or a spy thriller scenario involving briefcases handcuffed to wrists and, launch codes being whispered in a parking garage.
I mean, that's what comes to mind. It's a very loaded term.
I was honestly half expecting you to show up in a trench coat today. Maybe with a fedora. Complete the look.
I left it at home.
But despite the title, we aren't talking about uranium or missile silos. We're talking about something that, in the modern economy, is arguably more radioactive than plutonium.
Your data.
Your
Radioactive is actually a fantastic word for it, because think about it. Once that data leaves your perimeter, once you paste that trade secret into a cloud service, it has a half-life.
Ooh, I like that, a half-life.
Yeah, it lingers. It gets absorbed into training sets. It gets logged for safety review, whatever that means. It doesn't just disappear when you close the tab. It's out there forever.
And that is the terrifying realization that triggers our whole deep dive today. The source material we're looking at calls it the catalyst.
Right.
It's that stomach-dropping moment where a user, and we can call him the paranoid operator for our purposes, realizes, I cannot trust this text box anymore.
It's the moment of severance. It's
Yeah.
a total break. The source uses the term the nuclear option to describe this really radical shift in behavior. It's about looking at ChatGPT, looking at Claude, at Gemini, all of them, and saying, nope, I'm out. I'm taking my ball and going home.
But in this case, the ball is a supercomputer, and home is, well, it's a bedroom.
A bedroom, a basement, a home office. Specifically, and this is the best part, we are talking about a gaming rig.
This is my favorite part of the deep dive today. We are tracking a user, the source material's author, let's call him Frank, who goes on this incredible journey.
And Frank is not, the chief information officer of IBM.
No.
He isn't running a server farm in some cold storage facility in Iceland. Frank is a guy who bought a PC to play Baldur's Gate 3.
Which, for anyone who hasn't played it, is this massive, graphically intense fantasy game. It has to render dragons, dungeons, magic spells, all in beautiful 4K resolution.
And to do that, you need a serious piece of hardware. I mean, you need a graphics card, a GPU that can cost as much as a used car. It's a beast.
Right. So Frank is slaying dragons on the weekend. But then he has this epiphany. He's looking at his computer tower, glowing with all those ridiculous RGB lights, because, of course, it has to have the lights.
It's mandatory. It adds frames per second.
Obviously. And he realizes, wait a minute, I have a Ferrari parked on my desk, and I'm only driving it on weekends to get groceries.
That's the pivot. That is the exact moment. He realizes that the very same hardware that's designed to calculate the trajectory of a magical fireball is perfectly optimized to run the neural networks of an artificial intelligence.
So today, our mission is to follow Frank's manifesto. It is a literal step-by-step guide on how to turn that gaming PC into what he calls a sovereign AI server.
And we're going to get into it. We're going to talk about data leakage, the trust deficit, and my favorite concept, why you might want to build a disposable hazmat suit inside your own Windows folder.
It's a great image. We're going from being a user of a service to being an operator of infrastructure.
And a fair warning to you listening, We're going to get into the weeds today. We're going to talk about Python environments. We're going to talk about the physics of GPU memory, and we are absolutely going to talk about the philosophy of ownership in a digital world.
But don't turn off if you aren't a coder. Please stick with us, because the payoff. The payoff is having a genius-level intellect that lives entirely on your desk, costs $0 per query to run, and never, ever snitches on you to big tech.
Total data sovereignty. That's the prize. And in a world where everything is tracked, logged, and monitored, that is a prize worth fighting for.
So let's dig into the why. Why on earth go through all this trouble? Why not just pay the $20 a month for ChatGPT Plus and call it a day? It's so much easier.
It is easier. But it all comes down to what our source calls the trust deficit.
Unpack that for us, because trust deficit sounds like something my therapist would bring up in a session.
Well, you're not wrong. It's not far off. Think about the relationship we have with these cloud providers. For the last couple of years, it's been explosive AI growth.
Oh yeah, a gold rush.
Everyone jumped on the bandwagon because it was just magical. It felt like science fiction finally coming true on your screen. But then, inevitably, the breaking point hits.
The moment the magic wears off and the anxiety starts to set in.
Exactly. Our source describes this so vividly. The managed services, they have limits. Maybe they go down right when you have a critical deadline. We've all seen that.
The dreaded, "we are experiencing unusually high demand" message.
Right when you need it most. Or maybe they censor certain topics. You ask for advice on a gritty crime novel you're writing, something with dark themes, and the AI refuses. It gives you a lecture because it violates a safety policy.
That's annoying for sure.
It's annoying. But the real driver, the thing that pushes people to the nuclear option, is fear.
The fear that the walls have ears, or I guess in this case the chatbot has logs.
Precisely. There's a fundamental trade-off we make every single day, often without even thinking about it. Privacy versus convenience.
And convenience almost always wins.
It almost always wins. It is incredibly convenient to open a browser tab, paste in your entire business plan or your buggy proprietary algorithm, and ask an AI to fix it or improve it. It takes seconds.
But the moment you hit enter,
you have handed that data over to a third party. You've made a copy. You've given them a license, if you read the terms of service, to use it. You've lost control.
and for a lot of people, and certainly for corporations, that's just a nightmare scenario. Data leakage isn't just some abstract buzzword, it's a lawsuit waiting to happen.
Absolutely.
If you upload your company's secret product roadmap to a public model, technically you might have just breached your own confidentiality agreement. You could get fired.
And we've seen this happen. There have been documented cases of engineers at major tech companies, I mean the big ones, pasting chunks of sensitive source code into public chatbots to help them fix a bug.
Oh no.
And poof, suddenly that proprietary code is part of the model's training data. It's out there. It might get regurgitated to a competitor who asks a similar question 6 months from now.
That is horrifying.
It is. So the nuclear option is the complete rejection of that trade-off.
Yep.
It's a person standing up and saying, I refuse to choose between being smart and being private. I want both.
And you can't have both in the cloud?
You can't. The only way to get both is to bring the AI home, to move away from that dependency on big tech servers
Wow.
and run everything on your own metal.
Your own metal. I really like that phrasing. It sounds so tough, so industrial. Okay, so let's get into the how, because I know what some of our listeners are thinking right now.
I can guess.
They're thinking, I'm not a coder. I don't know Linux. I don't know what a terminal is. It's just a black box with green text. This sounds like I'm going to completely break my expensive computer.
And that is a very healthy fear. That is a good fear to have. In fact, our source, Frank, he addresses that immediately. He calls it the paranoia check.
Right. Frank admits that the IT side of his brain was just screaming at him, Frank, do not run random Python scripts from the internet on your production rig.
Yeah.
Which is generally excellent life advice.
It is. It's rule number 1 of cybersecurity. If you mess up your main computer, that's it. You can't play Baldur's Gate. You can't access your family photos. You can't pay your taxes online. The stakes are deeply personal.
It's not like at work. When you break a server at work, you just file a ticket and the IT department fixes it. When you break your home PC, you are the IT department.
You are the IT department, the help desk, and the person who has to explain to your spouse why the computer doesn't turn on anymore.
So the natural instinct, and I know I've done this 100 times whenever I try to mess with code, is to use a virtual machine. You know, something like VirtualBox or VMware.
The sandbox.
The sandbox. A computer inside your computer. If it explodes, if the code is malicious, the real computer is totally fine. It feels safe. It's the responsible thing to do. But Frank says, No.
Frank says absolutely not. He has a great line in the source material, just fantastic. He writes, "VirtualBox is where GPU speed goes to die."
Ouch. Okay, so why is that? I thought VMs were the industry standard for testing weird stuff.
For standard software, yes, they are. If you want to test the suspicious PDF you got in an email, for God's sakes, use a VM. But AI is a different beast entirely. AI requires direct, raw, unfettered access to your graphics processing unit, the GPU.
That expensive card with all the fans.
That's the one. That card is doing the heavy math, the what they call matrix multiplications. It's the engine. It's doing billions of calculations in parallel.
It's the engine.
Is the engine. And when you put a virtual machine in the middle, you're adding all these layers of translation and abstraction. It's like trying to have a very detailed conversation through a thick glass wall.
You can shout, but it's not going to be a good conversation.
Right. It's slow, it's muffled, it's frustrating. The software has to talk to the VM. The VM has to pretend it has a GPU. Then it has to talk to the host OS. The host OS has to talk to the actual hardware driver. And the driver finally talks to the physical card.
That sounds exhausting.
It kills performance. You need what he calls native performance. You need the code to touch the metal directly.
Okay, so we can't use the safe, cozy virtual machine because it basically throttles the brain to a standstill, but we also don't want to destroy our main Windows installation by installing 50 different conflicting versions of Python. I've heard horror stories about DLL hell.
Oh, DLL hell is a very real place. It's a dark, sad place where you install Python for one project, and it works great. Then you need to update a library for another project, and suddenly your first project breaks, your system path gets corrupted, nothing works anymore. It is miserable.
It's enough to make you just give up on the whole thing. So what is the middle ground? How do we stay safe without slowing everything down?
And that is the solution.
Yeah.
This is phase 0. The setup. And specifically, it's a tool called the Python Virtual Environment, or VEN for short.
Frank uses that fantastic analogy here. He calls it the disposable hazmat suit.
It's a perfect visual, isn't it? Imagine your pristine operating system, your desktop, your files, your clean C users folder. That's the clean room. That's your living room with a nice white carpet.
Right. I want to keep my documents folder actually usable. I don't want 1,000 weird config files littering my desktop and my downloads folder.
Exactly. A virtual environment is like buying one of those cheap pop-up tents, setting it up in your backyard, and doing the dangerous, messy science experiment inside the tent.
I see.
You create a self-contained folder, a directory. You tell Python, hey, for this project, we're working in here. And then you install all your weird libraries, the dependencies, the risky scripts inside that one folder.
And so if the code acts weird, if you get that dreaded Python is not found error or things just start crashing and burning,
you just zip up the tent and throw in the trash. You literally just select the folder and hit delete. Poof, it's like it never happened. Your main OS, your living room, remains pristine. Not a drop of sludge on the carpet.
That's brilliant. That takes almost all of the anxiety out of it. It encourages experimentation.
Completely. It's a game changer for anyone who's been afraid to tinker. And the source even mentions how he's blurring out his own username path in the screenshots he provides.
I noticed that.
That's the privacy paranoia in action. Even in the tutorial explaining how to be private, he's practicing what he preaches. He's showing us that privacy isn't just a piece of software, it's a whole mindset. It's about being constantly aware of what you're exposing, even to your audience.
Okay, so we've got the hazmat suit on. We're safe from ourselves. Now we need the actual intelligence. We need the brain to put inside this machine.
This is phase 1, sourcing the local intelligence.
The software stack here, the platform, is something called LM Studio. It seems to be the weapon of choice for the sovereign user. It's the user interface, the player. But the real decision is the cartridge you decide to put in the player, the model.
That's right.
And Frank recommends a specific one, Llama 3.18b.
This is a really crucial choice, and it's worth breaking down. Llama is the family of open-weight models released by Meta, Facebook's parent company.
Which is so interesting, right? The irony is thick. Facebook, the company we all associate with, harvesting unimaginable amounts of data, is the same company giving away the technology that lets us keep our data completely private.
It is one of the great ironies of the current tech landscape. Meta releases the weights, which is basically the big mathematical file that constitutes the AI's brain, and then the community takes it and runs with it. But let's look at that number, 8B.
8B. That stands for 8 billion parameters. Now, to a normal person, 8 billion sounds like an absolutely massive number. But in the world of AI, isn't that kind of puny?
It's on the smaller side, for sure. It's the small size in a t-shirt lineup. For context, the big proprietary models like GPT-4 are rumored to have parameters in the
A
trillions.
trillion is 1,000 billion. So we're talking about something that's like 100 times smaller or more.
Exactly.
So why are we even bothering with this tiny 8 billion parameter brain? Won't it be stupid? Won't it just give us baby talk and get confused?
That is the common misconception, and it's a really important one to clear up. You don't need a trillion parameters to be smart. You need a trillion parameters to know everything.
Okay, what's the difference?
If you want an AI that knows the capital of every country on Earth, the complete lyrics to every Taylor Swift song ever written, the chemical composition of obscure rocks, and can also code in COBOL from the 1960s, then yes, you need a trillion parameters. It's a storage issue as much as an intelligence issue. It's an encyclopedia.
Got it. It's a giant database of facts.
A giant database with a reasoning layer on top. But if you just want pure reasoning, if you want something that can take a paragraph of text you provide, understand the internal logic, identify any contradictions, and summarize it accurately, you can do that with a much smaller brain.
So 8 billion is the sweet spot for a reasoning engine, not an everything engine.
Precisely. It's not a trivia master. It's a logic processor. It doesn't need to know the population of Peru if you supply the population of Peru in the prompt. It just needs to know how to do the math with the number you gave it.
That makes so much sense. But even an 8 billion parameter model, that's a big file, isn't it? How do we fit that onto a consumer gaming card? I mean, VRAM, the video memory on the GPU, is precious real estate.
It's the most precious real estate in computing right now. And that leads to the next critical technical detail. And this is where the real magic happens for home users. The concept is called quantization.
Quantization.
And specifically, a setting that Frank recommends called Q4KM.
It sounds like a droid from Star Wars. Hey, R2, meet my new protocol droid, Q4KM. What is that actually doing to the model's brain?
To understand this, we have to understand what a parameter physically is. In the raw original model file, a parameter is a number.
Yeah.
Usually it's a very, very precise number with a lot of decimal places. Like imagine the number pi, 3.1415926535, and so on.
Okay, a high-precision floating point number.
Exactly. And storing that very precise number takes up space, 16 bits of space usually. But quantization comes along and asks a really radical question. Do we really need 16 decimal places of precision for this one neuron's weight? Or can we just say, it's about 3.14?
So it's literally rounding off the neurons. That sounds incredibly risky. Doesn't the AI get, brain damage from that?
It gets a little bit dumber. That is the trade-off, you're right. But it's a surprisingly graceful degradation. The best analogy is an MP3 file. When you rip a music CD to an MP3, the algorithm throws away some of the audio data that the human ear can't really hear anyway. The file gets way, way smaller, maybe 10% of the original size. But the song sounds basically the same to most people.
Got it. So quantization is like JPEG compression for the AI's brain.
That is a perfect way to put it. It compresses the numbers. And this specific Q4KM setting is what the community has found to be the sweet spot between speed and smarts.
The Goldilocks zone.
The Goldilocks zone. It shrinks the brain just enough so it fits comfortably onto a consumer graphics card with, say, 8 or 12 gigs of VRAM, but not so much that the AI becomes incoherent and starts spouting nonsense.
And the result of all that, after it's been quantized down, what's the final file size?
4.92 gigabytes.
Get out of here. That's it.
That's it. 4.92 gigabytes of sovereign, powerful intelligence sitting on your hard drive.
That is just staggering to me. I have video games on my hard drive right now that are 150 gigabytes. The latest Call of Duty is like 200 gigs with all the updates.
I know.
And you're telling me I can fit a reasoning engine that rivals a very smart human in many tasks into less space than a single high-def movie file?
Yes. You could put this model on a cheap thumb drive, swallow it if you had to, and walk across a border. That is the absolute definition of sovereignty. You physically possess the intelligence. It's not in the cloud. It's in your pocket.
And here is the most important part, the whole point of this exercise. It requires no internet connection to run.
Zero.
You could pull the Ethernet cable out of the wall, turn off the Wi-Fi, go live in a bunker in the mountains, and that 4.92 gigabyte brain would still work perfectly.
It would.
Yeah.
But there's a catch. There's always a catch, isn't there?
There always is. So if I have this genius brain in my bunker and I ask it, hey, Llama, who won the Super Bowl yesterday? What happens?
It will look at you blankly. Or worse, it will hallucinate an answer. It will confidently tell you that the Buffalo Bills won, finally.
Ouch. Too soon.
Because it's trapped in a box. Its training data, its entire memory of the universe, cuts off whenever Meta finished building it, which was probably months or even a year ago. It knows nothing about today. It is air-gapped in a way that severely limits its utility for real-world tasks.
Right. It's a genius, but it's a genius who's been locked in a basement since 2023 with no windows, no phone, and no newspaper.
Exactly. And this brings us to phase 2. And honestly, this is the real breakthrough of this entire deep dive. This is where we go from a cool science experiment to an actually useful daily driver productivity tool.
This is where we need to give the AI hands.
The hands. This is where a tool called FastMCP comes into the picture.
FastMCP, it's a weird name.
It stands for Model Context Protocol, but don't worry about the acronym. Just think of it as the AI's nervous system.
Okay, so if Llama is the brain, FastMCP is the nerves that connect it to the outside world.
Correct. The source material describes a very clever setup involving a Python library called FastMCP and a specific simple script called server.py.
Now, wait a minute, hold on. We just spent all this time talking about how we want to be offline, how we want to be secure in our bunker. And now you're telling me the solution is to run a server script. That sounds like we're opening a door we just triple bolted.
This is the nuance, and it's brilliant. The server.py script is the only piece of this puzzle that ever touches the internet. The AI model itself, that precious 4.92 gigabit brain, stays offline. It never leaves the bunker. It never talks to the cloud.
So how does it get your information then?
It asks the script to get it. Think of it like a president or a CEO sitting in a secure, soundproof office deep inside the Pentagon, the SEIF.
Okay, the situation room.
The situation room. The CEO is not allowed to leave that room for security reasons. But they desperately need to know what's happening on the stock market right now.
So they have an assistant, an aide.
Exactly. They press a button on an intercom.
Right.
Go get me the current stock price of Apple. The assistant, that's our server.py script, goes out of the secure room, braves the wilds of the internet, gets the stock price, comes back, and slips a piece of paper with a number on it under the door.
The CEO never leaves the secure room. The assistant never enters it.
Precisely. All the synthesis, all the important thinking, Apple is down. What does this mean for our portfolio?
That happens inside the secure room with the brain. The simple, dumb fetching happens outside. We are building a fetcher agent.
Okay, that makes a lot of sense. But let's talk about the wiring, the practical part, because the source gets into the weeds a bit on how to connect these two things. The nice, pretty interface of LM Studio and this gritty black and white Python script.
Right, because there are two separate programs. LM Studio is the user interface. It looks like a familiar chat window, very user-friendly. The server.py script is running in a black terminal window looking all hackery.
Matrix style.
Totally. To make them talk to each other, you need to build a bridge. And that bridge is a configuration file called mcp.json.
It's a simple text file, a config file.
Yeah.
You go into the settings of LM Studio, you open this file, and you basically write a little note to it. You tell it, hey, just so you know, I have a special tool running on my local machine. Here is its address. If the brain ever needs something from the outside world, please use this tool.
And there's a specific technical gotcha here that Frank warns us about, something that tripped him up and nearly made him give up on the whole project.
Groans. The forward slashes. This part is so real.
Yes. The / incident. Explain this because it sounds completely ridiculous, but I know it's the kind of thing that drives people insane.
It is ridiculous, but it's the daily reality of computing. Windows, for historical reasons, uses backslashes for file paths, C users Frank.
Right.
The entire rest of the computing world, Linux, the web, Mac OS, and most open source software like this uses forward slashes, like C users Frank.
So Frank is doing the logical thing. He's pasting the file location of his script into the config file.
Copying it directly from the Windows Explorer address bar, like any sane person would.
And nothing works. Absolutely nothing.
Nothing works. The bridge doesn't connect. He's getting errors, failures, silence, and it's all because of a tiny, invisible syntax error that stops this multi-billion parameter supercomputer dead in its tracks.
It's just such a human moment in the story. You're building this incredibly complex cyberpunk future tech. You have a GPU capable of trillions of operations per second, and you get completely defeated by a typo.
It's humbling, but he figures it out. He swaps the backslashes for forward slashes. He saves the mcp.json file. The bridge finally opens, and then it's time for the test.
The controlled breach.
I love that term so much. A controlled breach. Sounds like something out of a heist movie. Okay, team, we're going to breach the vault on my mark.
Exactly. But in this case, we are the ones breaching our own air gap.
We are. And usually in the world of cybersecurity, a breach is the worst possible thing that can happen. It means you've been hacked. It means you lost. But here, the breach is intentional. You are strategically puncturing your own defenses, but strictly on your terms for a very specific purpose.
So Frank tests this newly wired system. He fires up LM Studio, loads the Llama model, and what's the first question he asks?
He asks the local Llama model to check the top story on Hacker News.
A classic test. Hacker News is a tech news aggregator. The front page changes constantly, every hour, every minute sometimes.
Right, so if the model is just reciting its static, baked-in memory, it'll fail spectacularly. It'll either tell you about a big story from 2023 or just completely hallucinate something plausible sounding.
Which is what you normally expect. The expectation with local models is usually, frankly, disappointment when it comes to real-time info. You expect it to say, I'm sorry, as a large language model with the knowledge cutoff, I don't have access to real-time information.
That canned response? But that's not what happened.
What happened?
It didn't hallucinate. It didn't apologize. Instead, in the LM Studio interface, a little tools icon flashed for a second.
The hands. It was using the hands.
Hands went to work. The brain recognized, I don't know this answer internally, but I have been told I have a tool that does. So it sent a specific structured command to the server.py script. The script, our little assistant, went out to the internet, fetched the live, raw HTML from the Hacker News front page, which at that moment had stories about Capital One and Brex, and it fed that raw text back to the brain.
And the brain read it and summarized it.
And the brain summarized it perfectly in natural language.
That is the receipt. That's
Yeah.
the proof of life for this whole system.
It is, and we need to pause and think about the privacy win that just occurred there. This is so crucial. The reasoning, the part where the AI read the messy HTML, understood the context of the Capital One story, and composed a summary. All of that happened on the GPU in Frank's bedroom, 100% locally. Zero data about what he was asking or how he was analyzing it was sent to OpenAI or Google or Microsoft or anyone. The only thing that went out over the internet was a generic anonymous fetch request for a public URL.
So let's apply this to a more sensitive scenario. If I'm a lawyer and I'm analyzing a highly confidential legal document and I need to cross-reference a specific clause with a news article that was published this morning.
The confidential document stays on your machine. The AI reads it locally, then it sends the fetcher agent out just to get the public news article. It brings the text of the article back into the secure bunker. The synthesis, the magic of connecting the two documents, happens locally.
You have maintained the perimeter while still accessing the world?
That's the power. It really changes the entire dynamic. It stops being about just being paranoid.
Yeah.
It becomes about being in control. It's about being the gatekeeper. You decide what, if anything, ever leaves your house.
And that leads us directly to the philosophy of all this. Because Frank didn't just write a technical tutorial, he also wrote a LinkedIn post comparing what he built to what a major global bank is doing.
Yes, the BNY Mellon comparison. I saw this post. BNY Mellon, this huge ancient global bank, had just announced they deployed 20,000 AI agents across their enterprise.
Which, on the surface, sounds incredibly impressive. That is a massive corporate deployment. It shows the scale at which enterprise AI is moving.
It's a big number.
But Frank's post says, that's cool, but I'm actually more excited about the single agent I got running on my gaming rig this morning.
It's the classic David versus Goliath narrative, but applied to compute power and AI.
So why? Why is that one single homebrewed agent more exciting to him than 20,000 corporate banking bots?
It's because of who it answers to. Frank points out this critical distinction. Corporate agents, he says, answer to a risk committee.
Oh, don't they ever? They answer to legal compliance, PR.
They are guardrailed to death. They are monitored. They are heavily censored. They're designed, first and foremost, to protect the corporation from liability. They won't answer certain questions. They log every single interaction for auditing. But the local agent, the one on your gaming rig,
It answers only to me.
it answers only to me, the operator.
It's the difference between driving a company car and driving your own souped-up hot rod. The company car has a speed limiter, a GPS tracker, and probably a camera facing the driver.
Absolutely.
Your car goes as fast as you dare to drive it, and nobody in the world knows where you're going.
That's the perfect analogy. And Frank's core point is that you don't need a $20 billion IT budget to have that power anymore. You just need a consumer GPU. Maybe it costs a few $100, maybe $1,000 on the right wiring. FastMCP is that wiring.
It really feels like it democratizes the raw power of AI. For a while, we've been told that AI is this massive industrial thing like a nuclear power plant, that only the giants like Google and Microsoft can build and operate.
A centralized model.
Exactly. And this whole deep dive is saying, no, that's not the only way. You can build a pretty powerful little reactor right in your bedroom.
Which brings us back to that central, provocative question that Frank poses in his writing. Are you building on someone else's cloud or on your own metal?
It's really a question of ownership, isn't it? When you build on the cloud, you are a tenant, you are renting, you can be evicted at any time, the rent can go up without notice, the landlord can change the locks.
But when you build on your own metal, you are the landlord.
The sovereign landlord.
The sovereign landlord. You make the rules.
So let's wrap this all up with a verdict. We've gone on the journey, we've seen the setup, the disposable hazmat suit, we've seen the brain, the quantized Llama 3.1 model, we've seen the incredible breakthrough FastMCP giving that brain hands to touch the world. What is the final word from the expert based on our source? Should our listeners actually do this? Adopt or skip?
The verdict from the source is an emphatic, all caps, ADOPT.
Okay. Why? Give me the elevator pitch for adoption. Why should someone go through this hassle?
Two huge reasons. First, the one we've been hammering on. Total, uncompromised data sovereignty. If you have secrets, personal secrets, professional trade secrets, or just because you value privacy as a principle, this is the only way to truly keep them while still leveraging modern AI. But second, and this is a big one we haven't touched on much.
What's that?
Zero per token cost.
Oh, right. The money. We didn't even talk about the money aspect.
Once you own the hardware, the thinking is free. You can run that Llama model 247, ask it a million questions, have it summarize the entire internet, help you code for 8 hours straight, write 10 novels for you, and it costs you nothing but the electricity to run the machine.
No subscription fees, no API bills that give you a heart attack at the end of the month because you paid for every single word the AI generated.
None of that. It's a capital expense, not an operating expense.
That is incredibly compelling. It's an investment up front, maybe a significant one, but then it's infinite utility forever.
Yeah.
But surely it's not for everyone. Who should skip this?
No, you're right. There is a very strong caveat here. The skip verdict is for anyone on a locked-down corporate laptop.
Ah, the irony. The people who might need the security and privacy the most
Are often the ones whose hands are tied. You need administrator rights on your machine. You need to be able to install Python, manage these virtual environments, mess with configuration files, open up local server ports.
Things your IT department would have a fit about.
Exactly. If your IT department has locked your USB drives and prevented you from installing any unapproved software, you are not building a sovereign AI server on that machine. It's just not possible. You need control over your own machine to build this.
So this is really a call to action for the personal computer, the home lab enthusiast, the gamer with a rig that's gathering dust during the week.
It is. It's a call to reevaluate the hardware you already own. Maybe it's time to dust off that gaming PC. Maybe it's time to realize that the machine you use to kill goblins and race cars is actually the most powerful privacy tool you own.
AI, frankly. No hype, just receipts. That's how Frank signs off his tutorial. And I think we've seen the receipts today, loud and clear.
We absolutely have. We've seen that it's possible. It's a bit messy. Sure, you have to get comfortable with a command line. You have to worry about silly things like forward slashes. But the payoff is ownership. True ownership.
And in a world where everything is a subscription and all our data lives in the cloud, ownership is a truly radical act.
It really is. It's a statement.
So here's our challenge to you, the listener. You've heard the theory, you've walked through the process, you know about the hazmat suit and the fetcher agent. The question is, are you content with renting your intelligence from a handful of mega corporations? Or are you ready to own it?
It's a nuclear step to take, for sure. It's a big change in how you work. But once you push that button, you might find you never, ever want to go back to the cloud.
Thanks for listening to The Deep Dive. Go check your GPU specs, and we'll see you next time.
Stay sovereign, everyone.